today's lesson is 4:1 radian and degree measure. There are some different Greek letters that we could use to represent angles, and they're right here in this box. The little alpha symbol, the B for beta, and the theta symbol. Those are just some of the few symbols that you might see to represent some of the angles that we'll be working with. Down here at the bottom you see an example of a positive angle. A positive angle will start right here in the standard position, the initial side right here on the x-axis, and would go in the counterclockwise position, and that would be approximately 135 degrees. That would be a positive angle. And a negative angle would start in the same standard position right here on the x-axis, but it would go in the clockwise position around this way. And so this is an example of a negative angle, and this angle would be approximately negative 225 degrees. So this just gives you an example of which direction positive angles go and negative angles. Alright, coterminal angles are angles that have the same initial and terminal side. In other words, they start and they stop in the same place. So we're going to do 180 degrees and 540 degrees right here on the same graph. We're going to graph each of those. So 180 degrees, we would start in the standard position, and 180 degrees would go around and stop right here, halfway around the circle. So that would be 180 degrees. So I'm going to use blue to represent 180 degrees. Ooh, what happened with my pen there? Alright, let's try that again. Alright, so 180 degrees is blue. And I'm going to switch over to red for 540 degrees. I'm going to still start in the standard position on the x-axis, and for 540 degrees I will have to go all the way around the circle. That would be 360 degrees, and then I have to go 180 more to equal 540 degrees. So one complete revolution would be 360, plus 180 more would be 540 degrees. But if you notice that both of these both of these angles started and stopped in the same position, that's why they're called coterminal. They started and stopped at the same place. And the next thing on this page is, it's a little bit different, I think it's the top of your next page, is converting degrees to radians and radians to degrees. We've already done this, but I wanted to do just one quick review of each of these. You don't actually have examples on your paper, so I'm just going to do one on each side. Let's convert 100 degrees to radians, and then down here we're going to convert 3/5 pi back to degrees. Just to review, even though we've already done it, we'll just review this real quick. So to convert degrees to radians, we multiply by pi over 180. So I'm going to take 100 degrees, I'm going to multiply it by pi over 180. So basically I'm going to reduce 100 over 180, and that reduces to 5/9, and then I still have my pi. So 100 degrees converts to 5/9 pi. Now let's go the opposite direction. Radians to degrees. 3/5 pi, to convert to degrees, I multiply by 180 over pi. So I'm going to multiply by 180 over pi. Well, this pi is sort of like being in the numerator. It's like having 3 pi over 5. So I'm going to cancel out the pi's and do 3/5 times 180, and that is 108 degrees. So that's converting radians to degrees. So there's a quick review of that in case you had forgotten. Okay, we just drew coterminal angles, but now we're going to find coterminal angles. To find them, you're going to add or subtract 2 pi, which is a complete revolution. Now if we're not dealing with radians, like this example we're dealing with radians, what if we're dealing with degrees? Well, a complete revolution as far as degree degrees goes would be 360. So let's add or subtract 2 pi or 360 if you're dealing with degrees. Okay, because I know there's some in the homework where you're dealing with degrees and we just don't have examples on here. So you're going to add or subtract 2 pi or you're going to add or subtract 360 if you're dealing with degrees. So find two angles, one positive and one negative, that are coterminal, means they start and stop at the same place, with the angle 7/6 pi. So I'm going to have 7/6 pi, and I'm going to add a complete revolution in the positive direction, and then I'm going to come over here and I'm going to have 7/6 pi, and I'm going to subtract a complete revolution. In other words, I'm going to go in the positive direction and I'm going to go in the negative direction. Well, in order to add fractions, I need a common denominator. So this is going to be 7/6 pi plus 2 over 1 would turn into 12/6 pi, which would be 19/6 pi. This would be my positive coterminal angle. Got a little extra squiggly on my pi there. Let's try that again. Okay. 19/6 pi, that would be my positive coterminal angle. Now let's go in the negative direction. 7/6 pi, subtract a complete revolution, same common denominator. 7/6 minus 12/6 would be negative 5/6 pi, and that would be your negative coterminal angle. So if we're dealing with degrees, remember if this angle is degrees, you would just add 360 and subtract 360. Go all the way around positive and all the way around negative. Okay, complementary and supplementary angles. Let's go back and do a little geometry example off to the side. If I want you to find the complement of 20 degrees, and then over here I want you to find the supplement of, let's say, 30 degrees. Just plain old regular geometry. Think about how you would do that. Complement and supplement. If you want to find the complement of 20, complementary means 90 degrees, so you would say 90 minus 20 would equal 70 degrees. Right, so the complement of 20 would be 70. Alright, let's come over here and let's do supplement. Supplement means 180. So 180 minus 30 equals 150. So the supplement of 30 would be 150, because complementary is 90 degrees. Oh, that's already there. And supplementary is 180. So if you know, think about what you know from geometry. To find the complement of an angle, you subtract that angle from 90. To find the supplement of an angle, you subtract that angle from 180. Well, we're going to do the same thing, but now we're dealing with radian degrees, or radian measures, instead of degrees. So we want to find the complement and the supplement of 2/5 pi. Well, 90 degrees as a radian is pi over 2. 180 degrees as a radian is pi. So thinking about what we did back in geometry, to find the complement, instead of using 90 degrees, I'm going to use pi over 2, and I'm going to subtract my angle, just like I did over here. And then to find the supplement, I'm going to take 180 degrees, which is pi in radians, and I'm going to subtract my angle. It's just I'm using radians instead of degrees. Now I need to get a common denominator. My common denominator here would be 10. So 1/2 pi would be 5/10 pi. minus, this would be 4/10. So 5/10 minus 4/10 would be 1/10 pi, or pi over 10. So this is my complement. There's my complement. Alright, my supplement, my common denominator here would be 5, so pi would be 5/5 pi minus 2/5 pi, which would turn out to be 3/5 pi. And this is my supplement. On this next example, we are going to be looking for arc length. So let's talk about the formula before we try the example. Arc length is the measure around the outside of the circle. So this right here is an arc. Okay, it's part of the circumference. I don't know why S represents arc, but S right here is the arc length. So it's part of the circumference, part of the outside of the circle. Let's talk about the formula here. So the S right here is arc length. R, that's pretty obvious. I think everyone would know that that is radius. Okay, this is extremely important right here. This little theta symbol right here that represents our angle, but our angle must be in radians. Okay, it must be in radians. That means you're going to have to do some converting. You have to have your angle in radians. That's the place where most people will mess up. You've got to put your angle in radians, because look right here. That's not radians. So you're going to have to convert. So just be careful. Let's see. Okay, so that's it as far as the formula goes. So let's try this problem. A circle has a radius of 4 inches. Alright, let's draw it. Here's the center of the circle. Radius of 4 inches. Find the length of the arc intercepted by a central angle of 240 degrees. So we need to draw an angle in the center of the circle to be approximately 240 degrees. And I think that this would be approximately 240 degrees. Okay, that looks approximately 240 degrees. So we are finding the arc length, which means we're finding this out here. Okay, we're finding out how long. That's not very straight. We're trying to find out how long this is. I'm trying to highlight the outside of that circle. That's not looking too hot, but y'all get the point. I'm trying to figure out how long that is out there. Alright, the first thing we need to do is, I'm going to write it real big, we are going to convert 240 to radians. Alright, convert. 240 times pi over 180 is going to turn into 4/3 pi. So that's radians. Excuse me. So 240 degrees is 4/3 pi radians. So when we plug in our formula right here, we've got to use 4/3 pi. Okay, so let's do arc length. S is arc length equals the radius, r, which is 4, times our angle in radians, which is 4/3 pi. At this point, all you have to do is calculate this. So you would calculate that in your calculator, nothing fancy, just multiply 4 times 4/3 pi. And this would be, I'm going to change those to little squiggly equal signs because it's approximately 16.76 inches. So around the outside here, that is approximately 16.76 inches. It's not inches squared because it's not area. It's approximately 16.76 inches. That would be, this would be 16/3 pi. Okay, last one for this section. We have another formula also. This is area of a sector. We have another circle, and this area is shaded in because we're not finding arc length anymore. We're not measuring around the outside of the circle. We're going to find the area of a portion inside the circle. We're going to find the area of this sector in here. So here's your formula. Area equals 1/2. You know what the R is. You know R is radius. But let's stress again the importance of converting here. This theta right here means angle in radians. Angle in radians. So you make sure you convert to radians. Alright, let's see what's happening on number 4. A sprinkler on a golf course fairway is set to spray water over a distance of 70 feet. So here's where your sprinkler is located. It's going to shoot water 70 feet. So that is your radius. Okay, it's going to shoot water 70 feet and it's going to rotate back and forth. And it's going to rotate through an angle of 120 degrees. So here's your angle, 120 degrees. Find the area of the fairway watered by the sprinkler. Hopefully you're already thinking ahead of me. What's the first thing we need to do? Convert. Convert 120 to radians. So 120 degrees times pi over 180 would turn into 2/3 pi. Alright, so when we plug in our formula, we don't plug in 120 degrees, we plug in 2/3 pi right here. So the area of our sector will be 1/2 r squared, so 70 squared times 2/3 pi. Now, let's simplify this as much as we can and then we'll type it in the calculator. If I do 1/2 times 70 squared times 2/3 pi, that's going to turn out to be 4,900. Fix that. 4,900 over 3 pi. Now if you tell me it's 4,900 over 3 pi square feet, that really wouldn't make a whole lot of sense to me. So go ahead and I would want you to calculate that in your calculator. I'd want you to go ahead and punch the whole thing and calculate it and tell me that that is approximately 5,131 square feet. Or you can tell me 5,131 feet squared, but it is important that you put your labels on there, that you say square feet or feet squared, because it is area. So don't just put feet, you got to put square feet or feet squared. And that wraps it up for 4-1.